Hello everyone, welcome to the second lecture of the first unit. So in the previous lecture, we have discussed about the definition of image and raster graphics. So we have seen that the image consists of an array of pixels which is arranged in rows and column, and each of the smallest element of the image is known as pixel. And we have seen that it is a image made of a function of x, y, where x and y are the coordinates inside the image. And every pixel, if we talk about the grayscale image, it has a value from 0 to 255. And if we talk about the color image has three channels R, G, and B. So if it is a 16-bit format for the color, then we have 2 to the power 16 total number of colors possible in a color image. And then grayscale image, we have taken an example where we are having different shades of gray and black and white we are having. Then the color image of 24-bit there, it will have 2 to the power 24 colors, means 16 million colors. And then we have discussed about the relationship between the image and the signal, how image can be viewed as a signal also. Then how a digital image is formed when a light fall on any object and that light is reflected and it is received by the sensor of the camera, then a digital image can be formed through the camera. Then raster graphics, vector graphic we have introduced, and we were talking about the pixels bitmap inside the raster graphics. That raster graphic is the commonly used image that we click on the mobile as a selfie or from the digital cameras. And it has certain extension like BMP, TIF, GIF, and JPG. And it's have origin back to the television history and the television technology it was used previously. And then we have seen that compression techniques, lossless and lossy compression, and when to use the raster file extension. So we have compared how lossless is different from the lossy picture. Then now we will continue with the raster graphic file and the extension type. So the main raster graphic extension below given here, each blend the type of compression, different compression, either the lossy or lossless, and color palettes in their own way, like the direct or index. So we have to choose one of the best for case by case basis, depending upon our priorities. So first one is JPG or simply JPG, which is lossy, and direct index is direct here. Sorry, it is direct, color palette is direct. So it is called as joint photographic expert group. It is the most common raster file that we use and one of the most common image type on the websites. So it extend its malleability means we can reduce the quality to shrink the file size, or bulk it up means we can make it big for impressive realistic graphics. So these are the best file size compromise for high quality photograph and other graphics, and they reduce the file size compared to the lossless format, but the direct color palette still offer enough quality to look great. So we have two types of color palette, direct and index, that we have discussed in the previous class. Second one is PNG8, which is lossless and index. Color palette is indexed. So PNG stands for portable network graphic, which is 8-bit. Here, the first and the lower end type of PNG, they use the lossless compression. There is no loss of image quality. For better image quality, here it is the lossless compression compared to the JPG, but is held back by its index color palette. So the some disadvantage, it's the index color palette here. So in most of the cases, other file formats are better except one, like PNG8. It is best for the web graphics that don't have their own background and will be overlaid over the others. So PNG8 is the best format to be used compared to other image types. So if we want to superimpose a custom header image over our existing web page background, then we have to use the PNG8 format. Then PNG24 format, which is lossless and direct. So portable network graphics 24-bit. So here we are having lossless compression and direct color palettes. And here PNG24 are capable of better quality images compared to JPGs, but they have larger file size because it is 24-bit. So these work best when the image quality is our top concern and we have some breathing room for how fast your site loads. Means we don't have to worry about if the site is loading, our website is loading slowly, but we want the best quality image here. Next is GIF, which is lossless and index. So GIF stands for graphics interchange format, and it is used for static images. GIF is really the best choice. Because of the lossless compression here, their file size tend to be big but the index color palette, it reduces the image quality as well. So GIF, we might have seen on the WhatsApp messages, the images with the very little time to, it's just like a small, very small video clip. So GIF truly shine through its animation. We are having animation here. And if you want a video clip that is quick within a few seconds, then GIF is the best choice. Graphic interchange format. Then the next format for raster images, BMP, bitmap picture, and it is lossless and it can be indexed or directs. So BMP are bit outdated. They are not used nowadays, but are best avoided. Sure, they have the high image quality, but it's not worth the gigantic file size because they are very large files. So it is outdated now. Next is TIF or TIFF, lossless, indexed or directs. So it stands for tagged image file format. So just like the bitmap images, TIF, they are best avoided for the web images, and their specialty is in how well they recover quality after manipulation. If some manipulation is done in the image, so they can recover it easily, making them a good choice for digital artists and print publishers. But their large file size, because TIF having very large file size, so it make them detrimental for the web by increasing loading time. So when you are going to load the web page, so it will take time because the TIF image inserted in those pages, they will take a lot of time to be loaded because their file size is quite larger compared to the other formats. Now let's have a look at this video.
Hey, I'm Hunter from SkillThrive, and today we're talking about raster images. Almost any photo you see on the internet is a raster image, and common file formats are JPEG, GIF, PNG, and TIFF. A raster image is composed of millions of tiny squares called pixels, and each pixel represents a single color, and together they create an image like this one. Another term you'll hear when working with raster images is bit depth, which refers to the amount of color information available for that file. The higher bit depth, the more color the file can store. You'll notice in Photoshop, you have the option to set bit depth when creating a new document. An 8-bit document is able to display 16.8 million different colors, and a 16-bit image is able to display trillions. For most images, 8-bit is all you need. So why would you ever use 16-bit? Flexibility when editing. If you're making a lot of edits to an 8-bit image, you'll eventually run into a problem called posterization. Posterization is when an image's apparent bit depth decreases and results in a poor color transition. You can see here that after just a few adjustment layers, the image begins to lose color information in the sky. One way to avoid this is to edit RAW files in a higher bit mode, like a 16-bit mode. Keep in mind though, JPEG images are already 8-bit. So starting off with one and trying to convert it to 16-bit has no benefit because that color information is already lost when it was saved as a JPEG. Therefore, be sure to edit RAW files if you want the maximum color flexibility when editing. So should you always edit in a higher bit mode? Well, it depends. Use 8-bit if you're doing minimal adjustments to an image and if computer performance is a concern. And use 16-bit when you're doing heavy editing and computer performance is not a concern. That's it for this Photoshop quick tip. For full Photoshop tutorials and tips like these, be sure to check out skillthrive.com. If you like our videos, please subscribe and give it a thumbs up.
So raster images, the software which can be used to create and edit the raster images is the Adobe Photoshop. So you can have a try it and go through the tutorials which are available on the YouTube also. So the next is the vector graphics. So making use of the sequential command here or mathematical statement or program which place lines or shape in a 2D or 3D environment, it is referred to as vector graphic. Means while we are using the mathematical equations and command to draw the lines or shape in any 2D or 3D environment, then it is known as vector graphics. Vector means something which has direction. So vector graphics, they are best for printing since it is composed of series of mathematical curves. So as a result, vector graphic print crisply even when they are enlarged. Means in case of pixels, in case of raster graphics, when you enlarge an image, pixel tends to blur, but in case of vector graphics, there is no such problem. So if we talk about the vector in physics, a vector is something which has magnitude as well as direction. And in vector graphics, the file is created and saved as a sequence of vector statements. So rather than having a bit in the file for each bit of the line drawing, we use commands which describe the series of points to be connected here. So as a result, much smaller file is obtained. So file extension for vector graphics is .svg. So if you use the editor like Inkscape, so as it will generate the SVG output. Then we have different other formats here: EPS, PDF, AI, and .dxf. So unlike the pixel-based raster images, vector images, they are based on mathematical formulas that define geometric primitives like polygons, lines, curves, circles, and rectangle can be drawn using those formulas. So vector graphics, they are composed of true geometric primitives that are described polygon lines, etc. So they are best used to represent more structured images like line art graphics with flat uniform colors. And most created images opposed to the natural images, they meet this specification, including, for example, while you are designing the logos, while designing the letterhead and the fonts. So inherently vector graphics are more malleable than raster graphics. They are much more versatile, they are flexible and easy to use. Lot of things you can do, and there are lot of easiness to use these vector graphics. And the most obvious advantage of vector graphics over raster graphics that vector images are quickly and perfectly scalable. मीन्स raster ग्राफिक्स के ऊपर क्या एडवांटेज है इसका कि वेक्टर इमेजेस को आप इजीली आप उसको इसमें मॉडिफिकेशन और चेंजेस आराम से कर सकते हैं. एंड देयर इज नो अपर और लोअर लिमिट फॉर साइजिंग द वेक्टर इमेजेस. कोई लोअर लिमिट नहीं है उसके साइज की, कोई अपर लिमिट नहीं है. अगर आप उसको एनलार्ज करेंगे तो उसमें ब्लरिंग नहीं होगी, जस्ट लाइक द raster ग्राफिक जिसमें पिक्सल्स ब्लर हो जाते हैं. सो द रूल्स ऑफ मैथमेटिक्स अप्लाई हियर identically to computation involving 2-digit number or 200-digit number here, and the formulas that govern the rendering of vector images apply identically to graphics of any size. तो जो भी हम फॉर्मूला अप्लाई करेंगे वो वेक्टर इमेजेस पर अप्लाई होगा, किसी भी साइज का अगर हमारी इमेज हो. So like the raster graphics, in case of vector graphics, we are they are not resolution dependent. जैसे raster graphics की resolution जितने ज्यादा इमेज का resolution हो उतनी better image होगी. वेक्टर ग्राफिक्स के अंदर रिजोल्यूशन का कोई कंसेप्ट नहीं है. दे आर नॉट रिजोल्यूशन डिपेंडेंट, एंड वेक्टर इमेजेस हैव नो फिक्स इंट्रिंसिक रिजोल्यूशन. उनका कोई फिक्स एक पहले से एक रिजोल्यूशन फिक्स नहीं होता. रेदर दे डिस्प्ले द रिजोल्यूशन कैपेबिलिटी ऑफ व्हाटएवर द आउटपुट डिवाइस. जो भी आउटपुट डिवाइस है, मॉनिटर, स्क्रीन, एलईडी वगैरह, उसकी जो रिजोल्यूशन कैपेबिलिटी है उसी के हिसाब से वो अपना आउटपुट देता है. Because vector graphics need not memorize the content of millions of tiny pixels, तो पिक्सल का कोई कंसेप्ट नहीं है, मेमोराइज नहीं करना उसको पिक्सल की वैल्यूज. सो द फाइल टेंड टू बी स्मॉलर हियर कंपेयर टू द रेस्टर काउंटर पार्ट. तो फाइल साइज यहाँ पर स्मॉलर होगा क्योंकि पिक्सल्स के अंदर जो रेस्टर में हम वैल्यूज स्टोर करते हैं हर पिक्सल में, वो यहाँ पर स्टोर हमें नहीं करनी. So overall vector graphics, they are more efficient and versatile compared to the raster graphics. So where are these vector graphics used for? So for graphics artists, illustrators and designer, they use vector graphics for a variety of reasons. First reason is scalability. So vector formats are good for projects that require scalable graphic, including scalable type and text. So example क्या हुआ इसका? Company and brand logos, they are displayed at different sizes. जो companies और brands के logos बनते हैं सबका display और sizes different होता है. They show up in the corner of a mobile application or on a roadside billboard. आप मोबाइल में उसको व्यू कर रहे हैं तो वो साइड ऑटोमेटिकली एडजस्ट हो गया. आप उसको रोड साइड पे एक बिलबोर्ड पर डिस्प्ले कर रहे हैं तो वो वहां पर उसका साइज, वो फाइल ऑटोमेटिकली उस पर एडजस्ट हो जाएगी. पिक्सल्स ब्लर नहीं होंगे. फाइल एक बार क्रिएट हो गई, वो स्केलेबल हो गई, चाहे आप उसका साइज छोटा करके कहीं और लगा दें मोबाइल में, या उसका साइज आप बड़ा करके बिलबोर्ड पर एक बैनर बना के लगा सकते हैं. So a logo created with vector graphics can be scaled up, उसका size बढ़ा सकते हैं, और scaled down without loss of quality. कोई quality का loss नहीं हुआ, और creating a larger file. So it was the scalability feature of vector graphic that result in its return after falling out of favor to raster graphic in 1980s. 1980s में क्या हुआ? Vector graphic was out of scene compared to the raster graphics because scalability feature was not there at that time. But when this feature came, it again returned to the market. So vector graphics, they were originally used in computer displays, in the 60s and 70s, and World Wide Web WWW, they worked on vector markup language. उन्होंने एक language use की, vector markup language, which evolved into a scalable vector graphics, open source language that contain vector and raster elements. Now, second category of people who use it for which purpose? For application and web development. Application and web development में इसका use है. So vector graphics, they are useful in application and web development. Why? Because web apps and the graphics they contain, जो web apps है हमारी और जो graphics के अंदर जो होता है, they contain must work with various screen size and device. For example, एक web application है हमारी Gmail, तो हम उसको मोबाइल में भी ऑपरेट करते हैं और अपने सिस्टम और डेस्कटॉप पे भी ओपन करते हैं. तो वहां पर हमारा जो ग्राफिक्स है वेक्टर, वो स्केलेबल है, वो स्क्रीन साइज के अकॉर्डिंग अपने आप को एडजस्ट कर लेते हैं. फॉर एग्जांपल, अनदर एग्जांपल, अमेजन वर्क लिंक इज अ मोबाइल ऐप दैट एनेबल अ फुली इंटरेक्टिव प्रेजेंटेशन ऑफ कॉर्पोरेट डाटा ऑन एन एम्प्लॉयज मोबाइल डिवाइस. Next is for animation purpose. So animated images, they are created using the vector files which provide for cleaner and smoother images. So अगला इसका जो यूज है वो एनिमेशन के अंदर है. उसके बाद कंप्यूटर एडेड डिजाइन है. सो कैड प्रोग्राम्स ये यूज होते हैं इंजीनियरिंग में, मैन्युफैक्चरिंग में, सिविल इंजीनियरिंग, मैकेनिकल इंजीनियरिंग. सिविल इंजीनियरिंग पीपल दे यूज फॉर डिजाइनिंग the outline of the building, and by the architects also. And for the in the mechanical engineering field, they are used to design different parts of a machine or automobiles. So CAD software is used for that purpose, and the result of the CAD software is the vector files, because these are scalable and they are easy to use with the mathematical formula. So that's why they are used in manufacturing and engineering design. Now, conversion. So a vector can be converted to the raster graphics. So printer and display devices are raster devices. So the output of the printer or the display screen, they are having the raster output. So we need to convert the vector images to the raster format before they can be displayed or printed. So the required resolution here, it plays an important and a vital role in determining the size of the raster file generated. So क्या रिक्वायर्ड रिजोल्यूशन है, वो एक इंपॉर्टेंट फैक्टर होगा कि हमें अगर रेस्टर फाइल में कन्वर्ट करना है वेक्टर फाइल को. सो वन थिंग टू नोट हियर दैट द साइज ऑफ द वेक्टर इमेज, जो वेक्टर इमेज जो हमें कन्वर्ट करनी है, इट ऑलवेज रिमेन्स द सेम, साइज विल रिमेन द सेम. So it is convenient to convert a vector file to a range of bitmap or the raster file formats, but going down opposite part is harder. Means coming from the raster to the vector is quite harder as compared to going from vector to raster. Vector से raster convert करना easy है, raster से vector को वापस convert करना बहुत difficult है. Now raster to vector. So image tracing in computing can be referred to vectorization, and it's simply the conversion of raster image to vector image. अगर हमें image को trace करना है कि image कहाँ से ये हमारी image generate हुई है, तो उस ट्रेसिंग करने के लिए हमें raster को हमें vector में convert करना पड़ेगा. So an interesting application of vectorization is to update images and recover work. अब इमेज को अपडेट हमें करना है और कुछ इसमें से रिकवर करना है, तो उस केस में वेक्टराइजेशन यूज होगा, raster टू वेक्टर कन्वर्ट करेंगे. सो वेक्टराइजेशन कैन बी यूज्ड टू रिट्रीव इंफॉर्मेशन दैट वी हैव लॉस्ट. सो एग्जांपल इज पेंट इन माइक्रोसॉफ्ट विंडोज, इट प्रोड्यूस अ बिटमैप आउटपुट फाइल. ओके, पेंट हम यूज किया होगा और आपने, तो वो एक बिटमैप आउटपुट फाइल जनरेट होती है पेंट से. सो इट इज इजी टू नोटिस जैग्ड लाइन इन पेंट. सो पेंट के अंदर वी हैव दे आर द एक तरीके की मैट्रिक्स बनी होती है, जैग लाइन बनी होती है इमेज के अंदर, बीएमपी इमेज के अंदर. सो इन दिस काइंड ऑफ कन्वर्शन द इमेज साइज रिड्यूस ड्रास्टिकली. So as a result, an exact conversion is not possible in this scenario. So due to various approximation and editing that is done in the process of conversion, the converted image here are not of good quality. So the images converted from raster to vector, they are not of good quality. Now the differences between the vector and raster graphics. So talking about the main difference between these two, here is that the raster graphics, they are composed of pixels, and the vector graphics, they are composed of different paths. Means we are having different lines that are connecting to each other. Raster graphics, फॉर एग्जाम्पल GIF और JPG, वो क्या है, एक सिंपली एरे है ऑफ पिक्सल्स. एरे ऑफ पिक्सल से वी आर हैविंग रोज ऑफ एरे एंड कॉलम्स ऑफ पिक्सल्स, of various colors which together form an image. तो pixel से एक image बनती है raster graphics के अंदर. So we can see the difference between the vector versus raster file. So in case of raster, we can see we are having the pixel here in the right side, different squares you can see in this zoomed part. And in case of vector, we are having our path over here. We are having the connecting lines in the image. So this is the difference between the vector and the raster graphics. So let's have a look at this video.
Hello design friends, and welcome to our new video. Today we're going to show you the differences between vector and raster graphics. Let's start with a quick explanation of raster graphics. They are made of millions of colored picture points. You may know them as pixels. Vector graphics are made of anchor points, which are defined by coordinates and mathematical formulas. Through paths, these anchor points can then be connected, rounded, and colored in. Let's look at some examples to see what that means. Because raster graphics have a limited amount of pixels, they become blurry when scaled up in size, whereas vector graphics are mathematically recalculated and scaling won't affect their quality. However, when we scale the graphics down, they both look good. And there's also a difference in file size. Take this flag for an example. The vector graphic has a file size of 152 kilobytes and consists of 2 elements. The raster graphic is 2.7 megabytes and consists of almost 200,000 pixels. When scaling the flag up in size, the file of the raster graphic also increases in size, proportional to its number of pixels. The vector graphic file, on the other hand, stays the same. So now that we know the differences, when do we use what? Raster graphics are used for almost everything, but it's best to use them for detailed images, whereas vector graphics are used for less detailed images such as logos, text, and illustrations. Raster graphics are created by us every single day. Every time you take a picture, save a JPEG file on your computer, or screenshot a certain snap on your phone, you create a raster graphic. With vector graphics, it's a little bit more complicated. Every anchor of every object has to be placed individually in a vector program. Both raster and vector graphics can be converted into the other file. Although converting a vector graphic is a lot easier because the computer can simply render a graphic as pixels. The raster graphic, on the other hand, has to be retraced with paths, and the outcome is often different to the original. The paths can also be created with an image tracing tool. The results of that can be either detailed, rough, or rather interesting. And that is it. Now you know the difference between a vector and a raster graphic. We hope you enjoyed this video. If you did, make sure to give it a thumbs up and subscribe to our channel for more. Have a lovely day, and we will see you very soon.
So this is how the raster and vector graphics look alike, look different. There is a difference. Now there is one software which can be used for vector editing, and that is Inkscape. So let's have a look at this software also.
Dear all, welcome to this new tutorial. Let's discover Inkscape, a great free solution to make professional vector drawings for Windows, Mac OS, and Linux computers. In just 11 minutes, we will see everything you can do with Inkscape as a beginner. Inkscape is a vector-based drawing software that works with SVG files, or scalable vector graphic files, that are often used in web development. SVG files describe graphics with a textual markup language readable by web browsers and very easy to manage and compress without losing quality like standard JPG and PNG bitmap files. When you open Inkscape, this starts from a blank document on the center, several drawing tools on the left, and useful panels and options on the right that we will see. On top, you get the main bar showing properties and options for the current tool enabled or object selected. There is also a dark theme you can select by going to Preferences, and then to Interface Theme. Before working, you may need to adjust the document page size with Document Properties. Just select the standard template to use and the measurement unit under Display Units above. Now let's see how to draw on Inkscape with several tools on the left side. You can drop rectangles, ellipses, regular polygons, and stars by clicking and dragging on the document. You can also draw 3D cubes and spirals in the same way. You can also adjust size, corners, and shape type on top. You can enable other tools to realize custom shapes and paths. With the Bezier tool, click to fix several vertices and drop consecutive segments, whereas click and drag to define tangents to curves with very good precision. Then close the shape or double-click to apply. Use the options on top to change the drawing mode, such as Spiral Path to drop arcs and circles, and B-Spline to drop B-Spline curves. Use the Freehand tool to drop segments by clicking twice, or draw freehand by clicking and dragging on the document. Whereas, enable the Calligraphic tool to draw artistic paths, correcting trace properties on top. With the Text tool, you can drop text and annotations. Click and drag to create a text area and then type in. If you overcome the text box, this becomes red in color and hides part of its content. In this case, just extend it as much as you need to show all. On top, adjust the font family, style, size, distribution, spacing, and orientation, and set the text color from the complete list at the bottom. These changes affect any selected text if you have. Use your mouse wheel while holding down the Control key to zoom in and out. You also have several graphic aids to make precise drawings, such as the horizontal and vertical rulers, showing your cursor position on the document, and several main guides you can drop by clicking and dragging from the rulers. On the extreme right, you can set all the snapping options. You can turn on and off all snappings, or choose to consider several object key points, such as paths, intersections, cusp and smooth nodes, midpoints, and more. You can also go to View, Split View mode, to move a separator that shows or hides all object fillings and strokes to catch the vector skeletons. Now, let's see how to edit objects with the Select tool enabled. Click on any object to select it, and click and drag it to move it. This shows its dashed box and several nodes you can use to scale the object. Hold down the Control or Command key to save its aspect ratio. Click once again on the object to rotate and skew it instead. Use Control or Command and X, C, and V to cut, copy, and paste. You can always undo with Control or Command and Z. Moreover, if you double-click on the object, you enable the corresponding drawing tool. For example, the Rectangle tool if you double-click on any rectangle, or the Spiral tool if you double-click on any spiral. At this point, you can drop another object or correct the current one by moving its white nodes. Whereas, if you double-click on any curve or artistic path, you enable the Edit tool, which can be used on several objects. Drag white circles to adjust curves, white squares to correct straight lines, and white rhombuses to make complex adjustments, such as the extrusion length of the 3D cube. On top, you can transform the selected object. Rotate it by 90 degrees, flip it horizontally or vertically, and adjust its visibility in case multiple objects overlap. Also, set the object position, width, height, and click on the lock button to save its aspect ratio anytime. To adjust any object or text appearance, you can open the panels in the bottom right corner. With Fill and Stroke, you can add any filling with Fill and any stroke with Stroke, Paint, and Style. You can apply any solid color and any linear, radial, or pattern gradient to both the filling and the stroke independently. You can also enable the gradient tool to manage the gradients by moving nodes or clicking and dragging over the object. Make sure to select any node to change the gradient color and pick any color at the bottom to fix the overall background color. You can also add blur and transparency at the bottom. When selecting text, the fill represents the text color and the stroke the contour around each letter. Also, in this case, you can apply gradients as you like most. If you click and drag on the document, you can select all the objects within your rectangular selection area. This way you can move, scale, and rotate these in one move. You can also right-click and go to Group not to perform the selection every time. In addition, you can select multiple objects and open the Path tab to apply several Boolean operations to unify, subtract, and combine objects in several ways. Inkscape includes other advanced tools you can use. Enable the Spray tool to drop multiple copies of a selected object as you brush, and the Tweak tool to move or deform selected objects and text according to the options chosen on top. Inkscape can also manage bitmap images such as files rendered in pixels. Go to File, Import, and browse for the image. You can include it within your document with Embed or add it as a link to keep your document small in size. You can move, scale, and edit the image as seen for other elements. In addition, you can go to Path, Trace Bitmap to convert the image into a group of vectors if necessary. With Inkscape, you can also apply special effects by going to Filters, Filter Editor. Extend the panel and go to New to define a new filter. Then select the effect to apply and click on Add Effect. Make sure to enable the current filter to check the effect result on the object. You can also apply several effects in series and drag and move any effect to change their order. Each filter is indeed a group of effects applied in series. These are saved for the whole document and can be applied on any object or group singularly. You find several filters ready to use within the Filters tab. Inkscape also includes an XML editor to check the resulted code of your SVG document in progress. Very useful in case it must be opened by browsers on the web. You can also right-click on any object and go to Object Properties to check and change their ID selector associated, or add interactivity functions to make the object responsive when clicked on Click, hovered with your cursor on mouse over, and so on. These require coding under a Smile, CSS3, and JavaScript formats, but we won't see these in this beginner tutorial. Please check our video description for additional resources about this. Now let's see how to save and export your project. Go to File, Save As, to save the document as an Inkscape or plain SVG file that you can open and edit again with Inkscape, or export directly for the web. You can also choose a low-size SVGZ file or a PDF to print your document. You can also render your document into a bitmap file with File, Export PNG image. Choose Page to export the whole document, Drawing to export just the document area filled with objects, and Selection to export just the selected objects you have. The white document background will be rendered completely transparent. Thank you very much for watching this super short tutorial.
So that is all about the Inkscape. So you can download the software. It is freely available on the web, and you can start using it for editing the vector graphics. lot of things are available. So you can go through the complete tutorial which is available on YouTube about the Inkscape and start working on this. Now in the next class, we will be going to the topic digital image representation. So we will stop here. Thank you.